Hello, my name is Gaurav Gupta and welcome to the lecture. Today's lecture we will discuss about assembly language programming. Um, Firstly, we will discuss about machine language instructions. Each personal computer has a microprocessor that manages the computer's arithmetical, logical, and control activities. Each family of processor has its own set of instructions for handling various operations such as getting input from keyboard, displaying information on screen, and performing various other jobs. This set of instructions is called machine language instructions, and machine language includes only binary digits, this zeros and ones, hexadecimal and octadecimal. A processor understands only machine language instructions, which are strings of zeros and ones. In the computer, all data like videos, programs, pictures are represented in binary. The CPU processes this machine code or binary data as input, then an application or operating system gets the resulting output from the CPU and displays it visually. And the machine language is ambiguous and difficult to use in software development. And other hand, the uh, the low level assembly language is designed for a specific family of processor that presents various instructions in symbolic code in a more understandable form, and a programmer can easily write a program in alphanumerical symbols instead of zeros and ones. Meaningful and easily memorable symbols are chosen for the purpose. And for definition, a language that allows instructions and storage location to be represented by letters and symbols instead of binary numbers is called assembly language or symbolic language. These symbols are called mnemonics. Uh, for addition, we use add, addition, ADD, and for subtraction we use SUB. For comparison we use SMP, CMP. Um, Mnemonics in used in machine assembly language to represent instructions, and assembly language is a low level programming languages for microprocessor and other programmable devices. Um, an assembler, a software tool, or we can say it is a program designed to simplify the task of writing computer program. And in other words, a program which translates an assembly language program into a machine language program is called assembler. Format for assembly program. Uh, it has four other different parts: label, opcode, operands, comments. Label and comments are optional parts, but opcode and operands are a mandatory part. Opcode is a symbolic abbreviation for that operation, codes or command to the assembler. It specifies how operand are to be manipulated, which is residing within a microprocessor register or in the main memory. For example, ADD, which stands for addition, MOV, which stands for move, and MVI, which stands for move immediate. Uh, Operands are the variables which the assembler can manipulate. Users can tell the assembly language which data to apply whatever command on the line by including operands in instruction. Some of course requires no operand, some requires only one, some needs two operands, some needs three operands. When more than one operand is needed, the comma symbol is used as a separator between the operands. Labels are placed at the beginning of the line. In the below example, we can see loop is a label and assigns a symbolic name to the address corresponding to line. Comments are started with a semicolon and it may contain any printable character or it may be a blank. In below example, at the after semicolon, all the written thing is called comment. In this comment states what is the program want to say. Add the value in rational B to accumulator A. Directive. A directive is a kind of instruction that informs the assembler how to change a setting or perform an action. An assembly language syntax frequently requires a specific character such as period at the start of a directive. It instructs the assembler that the following text is a directive to follow. And in simple words, directives are commands that are part of the assembler syntax but are not related to the processor instruction set. And all assembler directives begins with a period, full stop, or you can say dot. Arithmetic operations in assembly language programming based on 8085 or 8086 microprocessor. The 8085 or 8086 microprocessor performs various arithmetic operations um, such as addition, subtraction, multiplication, division, increment, decrement. For these operations, we use mnemonics. For addition, we use ADD. For subtraction, we use SUB. For increment, we use INR. For decrement, we use DCR. For multiplication, we use MUL. For division, we use DIV. And addition operation, the 8085 and 8086 operation performs addition with 8-bit and 16-bit binary numbers respectively and stores in the accumulator. This is an example for addition operation. MVI A24, which states the instruction loads the value 24 into the accumulator register A, and the MVI stands for move immediate and used to load a constant value into a register. MVI B07, this instruction loads the value 07 into the register B8B. This instruction adds the value in register B to the accumulator A. Add instructions adds the content of specified register to the accumulator and updates the flags accordingly. STA2000H. This instruction stores the result, the value in the accumulator, in memory location 2000H location. The STA instructions stand for store in accumulator. HLD stands for hold the processor, and now we will run this program on JNU simulator. This is a type of assembler, and now we will run on NVI four NVI B7. Let B set the value in register B to the accumulator A. ST means store the result in memory location 2000H and LT. Now we will run this program by line. Now we go to the location of 2000H. And second step, we went to the MVI B7 addition and the value stores at the location of 2000. The data is 31 and at the exponential value is 1f. Now we will change the value 1f to decimal. This is 31 and this is the example of addition operation. Now the other is subtraction operation. The 8085 performs subtraction by using the method of 2's complement. Following steps internally execute to perform the instruction SUB. In first step, we convert the number to be subtracted into one's complement. Then we add 1 to the one's complement to obtain 2's complement of the number to the subtracted. Then we add 2's complement the content of the calculator. The complement will be stored in the carry flag. This is the example of subtraction operation. LXI H1000H, which means the load HL pair is immediate with 1000H location. MOV which means copy the operand from memory into accumulator. INXH means increment dash pair by 1. SUPM means subtract second operand from accumulator and store result in accumulator. INXH means HL pair incremented by 1. MOVMA store result at 102H and HLT means terminate program execution. Now we will run this program on GNU simulator. LXI. This is a location. And copy the operand from to the incrementer. H increment HL pair by value 1 and subtract the value of second operand from the incrementer and H increment the HL pair address by 1 and store the value in location H at 2000 H location at the value of 56 and either value 30. Now we will start processing step by step. And second step, third, subtract and such remind the way HLD. Now we can see at the location of 1002 there is a value we got 33 and in accumulator we got 21. Now we will convert it into decimal and this will be decimal is 33 and hence this is the subtraction operation. This is for today's video. Thank you and have a good day.